Your quiz is tomorrow. Here we go. Which means I'm actually going to tweak your quiz a little bit. Here we go. If there is a binomial in the numerator, this means I'm going to add a question on the stuff that we do today.
One question?
One or two.
Okay, that's not that bad.
Because it's 8 questions. It would be nice to make it 10 questions as opposed to 9 questions. Here we go. So this is just an extension of the stuff that we did yesterday. We're just going to add binomials to the numerator. And how you handle this, I mean, there is a trick is not the right word, but there is a finicky detail that you need to make sure that you follow when dealing with stuff like this. So the instructions are similar to what we did yesterday, with the notable exception of number 1. So we'll skip number 1 for a second. The rest of the instructions are looking similar. Find the lowest common multiple of the denominator, multiply every term by the LCM, simplify the fraction. If needed, distribute the number that remains. Or put this note in here. Instead of multiplying by the LCM, it is always an option to multiply by both denominators. Simplify, distribute, and isolate. Those are the key words there that we're going to follow. Multiplying by the LCM, simplifying the fractions will work. It is always more work. But I'll show you what both of these two options look like. I'll show you one over here and the other over here. For this one, I'll show you the LCM method first. Actually, you know what? No, I won't show you the LCM method first. I'll show you the second method first. So I've got 3x minus 1 over 3 equals 2x plus 7 over 5. When you've got a binomial in the numerator, it's important to recognize two things. The first thing is important to recognize is that this thing here, that numerator, that binomial, is a single mathematical object. And to make your life a lot easier, throw brackets around it, which is the step 1 here that I glossed over a second ago. To make it really clear what you need to do, put brackets around that numerator. It doesn't matter if it's a binomial or a trinomial, a 4-termed mathematical object, whatever it is, throw brackets around the entire thing. Then I'm going to demonstrate what this second thing looks like here. We're going to multiply by both denominators, simplify and distribute and isolate. So I've got a denominator here of 3 and I've got a denominator here of 5. What I'm going to do is I'm going to multiply, because I've got this thing now in brackets, I'm going to multiply on the outside here by 5 and 3. I'm going to multiply on this side by 5 and 3. Instead of multiplying by the LCM, for this one, I'm just going to multiply by each denominator. And now what we've got here is, well, I've got a binomial in brackets, multiplied by some stuff, and divided by something. When I multiply and divide by the same thing, those objects can cancel. So that 3 and that 3 are going to cancel there. And over here, what's going to cancel? The 5s. The 5 in the denominator and the 5 that I'm multiplying by are both going to cancel. So now what I've got here is 5 times, and then in brackets, 3x minus 1. Over here, I've got 3 times, and then in brackets, 2x plus 7. So this is now where we need to distribute, because we're multiplying this whole binomial by 5 and this whole binomial by 3. So we need to make sure that we multiply that number onto each term inside those brackets, and likewise on the right-hand side. So on the left-hand side, what I'm going to get is 5 times 3x. 5 times 3 is 15. The x comes along for the ride. 5 times negative 1 is negative 1. And that's all that's left because I canceled away my denominator already. Over here, I'm going to distribute this 3 that didn't get canceled into this thing. So 3 times 2x is 6x. 3 times positive 7 is positive 21. And now I've got an expression that looks very similar to what it did a couple days ago, or to what we had a couple days ago. I've got variables on both sides. I want to, yes, right. Yes, yes it is. You actually have to distribute everywhere, not just on the first term like I did. Thank you, Rain. That should be 15x minus 5. 5 times 3x is 15x. 5 times negative 1 is negative 5. Thank you. Now it looks an awful lot like what it's supposed to look like and like it did a couple days ago. I've got variables on both sides. So which way is it better to move our variables? To the left or all to the right? All to the left is going to keep them positive. Because I've got positive 15 of them over here and only positive 6 of them over here. To get them onto the left-hand side, what do I have to do over here? Careful. I want to move this whole term over. I want to get all of my terms with variables to the left. I want to get all my terms with variables. No, you're getting warmer. I don't want to minus 21 because that's going to bring the 21 over here. I want to get the variables by themselves. So I want these variables to join these variables. And this 6x here is positive. So I'm going to minus 6x on both sides. Minus 6x minus 6x. 6x minus 6x is gone. It's 0. So we're going to get 0 plus 21 is 21. Now I've got 15x minus 6x. 15 minus 6 is? Someone said 9. So I'm going to get 9x minus 5 equals 21. Oh, this looks terrible. So what's my next step? I've got 9x minus 5. I want to get the x's by themselves. So we're going to move over any term that doesn't have an x in it. We're going to add 5 to both sides. Negative 5 plus 5, gone. I'm left with 9x on the left-hand side. 21 plus 5 is? One more time. Sorry, Jackson. Yes, I think you were right, Jackson. Say it again. It is, in fact, 26. Now to get x by itself, we need to divide by 9, divide by 9. 26 does not divide by 9 cleanly. So this is just one of those fantastic fractions. You could convert it to a decimal if you want. It would be 2.6 repeating. 2.8 repeat. 2.9 repeat. 2.8 repeating. Because 9 goes into 26 twice, and then 26 minus 18 is 8. So it would be 2 and 8 over 9, which is 2.8 repeating. If you wanted to go that route. But leaving it as a fraction, totally acceptable, and I would encourage you to get comfortable with that. Okay, so this is, I'm hoping you're getting the idea here that this is my preferred method. And I think for a lot of you, once you get the hang of multiplying, instead of multiplying by the LCM, multiplying by each piece here and then canceling, I think once you get comfortable with that, it's going to work a lot better for lots of you. Because it reduces the steps where you could make a mistake. But for those of you who really like the idea of the LCM, multiplying by it, I'm going to show you what that looks like on this question here. So, in the second example that I've got today, I've got 2x minus 3 over 2 and negative x minus 1 over 4. Your best first option is to throw brackets around those numerators, representing that is a single mathematical object. That binomial is one thing. When we multiply something there, we have to multiply something onto each piece of it. So now I'm going to take a look at this thing and say, well, what is, if I'm going to use the other method, what is the lowest common multiple, or the LCM, of my denominators? Well, my denominators are 2 and 4. What is the smallest number that 2 and 4 both go into? What are the numbers that 2 and 4 both go into? They both go into 4. They both go into 8. They both go into 12. If you don't pick the lowest one, you'll just have some more stuff to simplify at the end. But if you can identify the lowest one, it'll make your life the easiest. The lowest of all the multiples is 4. Do you want me to go through again how we found that? They did that once upon a time. Does anyone want me to review lowest common multiples? Okay. Lowest common multiple of 2 and 4 is 4. So what I'm going to do is I'm going to multiply both sides by that LCM. What I need to do then is, when I'm multiplying by the LCM, before we distribute this thing in here, we need to say, okay, what is, I'm going to extend this line here to make it really clear what's going on. Before we distribute, this is the fraction we are going to reduce. What is 4 divided by 2? 4 divided by 2 is 2. This gets reduced, and my binomial in the bracket is still there. What's 4 divided by 4? 1. And multiplying by 1 doesn't change anything, so these 4s are just going to go away, leaving me with negative x minus 1 times 1. And now I'm going to distribute. 2 times 2x is 4x. Don't want to screw this up again. 2 times negative 3 is negative 6. Equals, does distributing a 1 change anything? No, multiplying by 1 never changes anything. So I can just drop the brackets on the right-hand side, and my binomial then is just going to be negative x minus 1, no brackets, because multiplying by 1 doesn't change anything. So now we're going to do the same thing we did before. I'm going to bring all my variables over to one side. I'm going to bring all my numbers over to the other side. So does it make the most sense to bring my variables left or right at this stage? Left. This is positive, this is negative. How am I going to get rid of this term? Sorry? Eventually we're going to add 6. Let's do my variables first. Actually, we could do them in the same step. Dilkaran, you're suggesting we add 6 to both sides. That's going to get rid of this. Let's do it in the same step. How am I going to get rid of this negative x? We're going to add x, you bet. So I can do both of these steps at the same time if you're getting comfortable with this. On the left, we need to make sure we also add x. And then let's look at what happens here. 4x plus x is 5x. Negative 6 plus 6 is gone. This is going to equal negative x plus x is gone. And negative 1 plus 6 is 5. If you organize your work, if you stack it the way I've been doing it all in one step is really quite easy. These are going to cancel. These are going to cancel. 4x plus x is 5x. Negative 1 plus 6 is 5. And then my last step is to do what? Yeah, divide both sides by 5. 5x divided by 5 is just x. And on the right-hand side, 5 divided by 5 is 1. And when that's the only thing there, we need to make sure we put it in there. So x equals 1 is our solution to that question. I didn't do it on the first one because it's the fraction and it's gross, but we can do this one relatively easy. Let's plug it back in and check. Let's do the check on the right-hand side here. Here's my check. I've got 2x minus 3 over 2 equals negative x minus 1 over 4. Let's see if this is true. I'm going to take 1 and I'm going to plug it wherever there's an x. So I'm going to get 2 bracket 1 minus 3 over 2 equals -1 minus 1 over 4. I'm just going to solve this thing using BEDMAS. BEDMAS says, well, and when we did these back with fractions a while ago now, you've got to treat that numerator like it's inside a set of brackets. That thing needs to get solved first. 2 times 1 is 2. 2 minus 3 is -1. So my left-hand side is going to become -1 over 2. Okay, my right-hand side, what's -1 minus 1? -2 over 4. Are those two fractions equal? Is -1/2 equal to -2 over 4? You bet. Because this guy's reducible. So this is true, so that is true. We're good. Again, whichever method you choose, multiplying by each denominator or multiplying by the LCM will both work. As long as you're following each step, as long as the steps are mathematically true, you'll be fine. The key here is, for regardless of which way you do it, make sure you throw brackets around your numerators so that you treat that thing as one large mathematical object. Okay, before I assign you your homework, I want all of you to take a look at both of these questions. I'll float around, I'll help where needed. All of you do these two before anybody goes anywhere. When you have answers, let me know. I've got them. You're ready to check yours. And then once you're ready to go, I will tell you what I want you to work on for home. So let's take a look. For the first one, lots of you are multiplying by 3 and 6. We're multiplying by, you're putting the brackets around, multiplying by 3 and 6. Again, the most common mistake I saw, and for anyone watching the video, you got to make sure you multiply this side as well. Times 3 times 6. Here, the 3's will cancel. Here, the 6's will cancel. This is going to give you 6n minus 6 plus 3n plus 6 equals, I have hiccups. This one, 7 times 3 is 21. 21 times 6 is 126. Now, if you've got this line correct, Hayden and Oliver. Oliver, you don't need to hold hands with Hayden. Hayden, you just need to pay attention to this. If you've gotten to this step successfully, what you need to remember is that the equal sign is over here. Anything to the left of the equal sign can just be grouped. 6n plus 3n is going to be 9n. -6 plus 6 is 0. So all I'm left with on the left-hand side is 9n equals, and the right-hand side is 126. Divide by 9, divide by 9, n equals 14. This you can punch into a calculator, or you can use your multiplication tables for, but that is the method. The most common mistake I saw, that guy right there. And even in there was a couple different mistakes I saw. Some of you didn't do this. Some of you said 3 times 6 was 9. There was a few mistakes all related to this piece here, which is actually good. That's a simple mistake to fix. If you're doing the left-hand side correctly, that's great. That's the hard part here. We can fix 3 times 6 not being 9 relatively easily. The next one was this. We're multiplying, lots of you are multiplying by 3 and 2. And after the discussion we had about the first one, lots of you are remembering to multiply this side by 3 and 2 as well. So that's great. Times 3 times 2 times 3 times 2. The 3's are canceling, the 2's are canceling. So I'm going to get, and I'm going to distribute in kind of all in one step. 2 times 4x is 8x. 2 times positive 5 is plus 10. 3 times negative 3x is negative 9x. And over here I've got negative x times 3 times 2 is negative 6x. Lots of you were able to successfully get to that point. Now I'm just going to group my like terms on the left-hand side. 8x minus 9x is negative x. And that plus 10 doesn't have any friends. So this is what we've got. Negative x plus 10 equals negative 6. Because I've got my numbers and variables over here already, I am going to add x to both sides, even though that's going to keep this thing negative. So I'm going to get 10 equals negative 6x plus 1x is going to be negative 5x. I'm at negative 6 going up 1 towards 0. I'm divide by negative 5, divide by negative 5, and you're going to get x equals 10 divided by negative 5 is negative 2. So if you are unable to get to the point where x equals negative 2, I'm hoping you can see your mistake in there. If you can't, call me over. I'll take a look at it. There is a boatload of practice that I've got for you. Here is where we're going to start. I want you guys to flip. You're going to start at part 3. I'm going to get you guys to do aces on part 3. A, C, E, and G. And then on part 4, those are all very similar there. So let's get you to do BDFs. BDFs, so B, D, and F. Aces on part 3, BDFs on part 4. Flip the page. I've got a part 5 going on over here. On part 5, these all look very similar. So I'm going to get you guys to do... No, not all of them. Let's do aces again. Let's do aces again. Again, and the answers are at the bottom for part 3, part 4, part 5. So yeah, I'll put them down here. I wanted aces here, BDFs here, aces over here. And then there's more. Flip the page. What do you mean how? There's always more. And it's only 10:20. You've got loads of time. You've got 35 minutes as of right now.
That's not long.
As far as the amount of time I could give you in class to practice, 35 minutes is almost half the class. That's pretty good. I want you to do the double cross page. What do you get when you cross an absent-minded elephant with a small flea? And what do you get when you cross a shark with a snowball? Yeah, but wait.
There's always more.
There's always more. I'll say that is where that's where it ends.
Yes.
If you flip the page, there is optional extra practice here.
Nope.
And you're writing me a quiz tomorrow. So that is the practice I want you to do. Shobit's around, I'm around. I'll help you where you need to go. If you've done those two practice problems, yes, Jackson and Liam, you guys can go to the Indigenous room. Yeah, right now. You've got your homework. The whiteboards are free. I would encourage you to use them. Get to it.